Nitric oxides enhances pressure natriuresis. Deficiency of nitric oxide synthesis impairs pressure natriuresis through various mechanisms, including hemodynamics and tubular effects. This mechanism can be modulated by processes intrinsic or extrinsic to the kidneys. Decreased endothelial-derived nitric oxide (EDNO) synthesis impairs renal sodium excretory function by increasing basal renal vascular resistance, enhancing the renal vascular responsiveness to vasoconstrictor such as angiotensin II or norepinephrine, or activating the renin-angiotensin system. Reductions in nitric oxide synthesis also impair sodium excretory function, either by directly increasing tubular reabsorption or by altering intrarenal physical factors such as renal interstitial hydrostatic pressure or medullary blood flow. Vascular nitric oxide is primarily produced from L-arginine by endothelial nitric oxide synthase (eNOS). Three distinct genes encode NOS isozymes which catalyze the production of nitric oxide from L-arginine. These genes include neuronal NOS, that is nNOS or NOS1, cytokine-inducible NOS, that is iNOS or NOS2, and endothelial NOS, that is eNOS or NOS3. The production of nitric oxide from L-arginine by NOS also requires the presence of various cofactors, including tetrahydrobiopterin BH4, flavin-adenine dinucleotide, flavin mononucleotide, calmodulin, and iron protoporphyrin 9. Tonic release of eNOS-derived nitric oxide by vascular endothelium play a major role in regulating vascular function, while nNOS and NOS-derived nitric oxide from renal epithelial cells regulate sodium transport and renal hemodynamics. Long-term inhibition of NOS causes sustained hypertension associated with impaired renal pressure natriuresis. The increase in blood pressure during nitric oxide inhibition depends on sodium intake, indicating that nitric oxide also regulates sodium balance and renal pressure natriuresis. Salt-sensitive hypertension caused by impaired nitric oxide production. Reduced nitric oxide synthesis is a key factor in the development of salt-sensitive hypertension. Enhanced renal nitric oxide production or release leading to increased urinary excretion of nitric oxide metabolites or the nitric oxide second messenger cyclic guanosine monophosphate is essential for maintaining normal blood pressure during a high salt diet. When this increase in renal nitric oxide production is prevented, it results in salt-sensitive hypertension.